let's just get going about types of data. First of all, this was just mentioned in the last lesson, but we have data that can represent a parameter or a statistic. Now, this statistic word is different than the class and the subject area and the field of study. A statistic and a parameter, in this case, both represent numerical measurements. So we're looking at numbers that we're getting. This is when we tell you the percentage of people, or the average number, or the standard deviation, all terms that we'll come to use more and more. But a parameter has to come from a population, and the population is all the members of the group. So if you're looking at the population of U.S. adults, it is all the U.S. adults. And again, you would need to define your group very carefully. Okay, you have to get very specific. A statistic is a measurement that comes from a sample. So in other words, it's not practical at all to think that you're going to get information from every single adult in the United States, in which case we're going to get some groups of people. Now, we want the group to be representative. That's good work. But even a poor sample is still a sample if it's just a sub-collection of the group. So statistic goes with sample. They both start with S, and a sample has some of them. A parameter comes from the population, and that population has to be everybody in the group. So you can use that first letter to kind of help you remember which one you're dealing with. And most of the time, you're going to deal with a statistic, because most of the time it's not practical to deal with the entire population unless the group you're interested in is fairly small and contained. Like an employer might be able to look at employee records and tell you what the average age of employees is in the company, because they have all the employee records. So you could get that if you were only looking at a small group in that way. So this is just a couple of examples of what your homework questions might look like, or practice questions. So as we go through here, we say, what is the population? And then what is the sample? So our population, I'm just going to kind of highlight, it saves me a little bit of writing, would be high school students in the U.S. Okay? That is the group that's being studied there. However, they did not ask all of the high school students in the United States. They asked 8,505 high school students in the U.S. So the what I've marked in parentheses then is the sample. It's those 8,505 that participated. Since our numbers come from that group and not everybody that they were looking at, this would be a statistic. Now, it's a pretty scary statistic if you actually read it. Almost half, 44.5% of those in this study texted while driving at least once in the last 30 days. Kind of scary. In our next one, what is the population is the question as you read through. What is the group that we're studying? The study of the adults in the United States. That's my population. What is the sample? The sample are part of that population that participated. So the sample is the 2,276 adults in the United States that participated in that study. And now again, since this came from not all of the population, but a portion of it, a small group of it, this one is a statistic. Unless it came from every member or all of them, you're dealing with a statistic. That's why generally the numbers that you hear are statistics. But even when you have a parameter or you have a statistic, it still can fall into a particular, is it quantitative data or is it categorical data? Now, quantitative data has to do with numbers. Best thing I can tell you, quantitative is numbers. And the numbers actually represent counts or measurements. The reason I say that is because you could use a number and it could be a label. It has to actually be a count or a measurement. And one that comes up within this, we're going to look at this example in a little bit, but like the number on a player's jersey, that's just a label. They haven't counted anything when they give a jersey number to a player. So that's a label. But this one has to do with numbers, and it comes from counts or measurements. Now let me just skip down. I will come back to this section, but let's skip down to the end. Then what if it's not quantitative? What if it's not a number? Then it's categorical. And categorical data deals with names and labels. So like that jersey number, that's just a label. That's categorical data. That's still just a label. So you can talk about player number such and such. Okay, so names and labels, categories. Quantitative has to do with numbers that came from counts or measurements. If it is quantitative, if it is a number, then we can break that down further and say this data might be discrete or continuous. Discrete data means that you can count it. You have to be able to take specific values on. It could involve a decimal if we were not rounding. Like if we just said, if you have 3 pennies, how many tenths of a dime do you have? Well, that's very specific. I have 3 tenths. So it could involve some decimals, but it would have to be that you are counting those decimals. Otherwise, most discrete data does not take on decimals. It deals with whole numbers. And then continuous data has infinitely many values because generally it is measured and rounded. So if you want to ask somebody any sort of a measurement, really, if you wanted to say, how tall is the building? Well, it might be an exact footage, but it might be to the nearest meter, or it might be to the nearest inch. Or they might, if you ask somebody their height, like I'm about 5 feet tall. Notice I said about, but I'm really 5 feet 5 inches. I might even be 5 feet 5.25 inches. Because when you measure, you just kind of have to decide how specific you're going to get and what to round it to. So continuous can involve rounding, and it generally comes from measurements. The measurements could take something in between what you're saying. Then that's when we're dealing with continuous. Discrete is very rarely involving decimals unless it's asking you to count how many of something. Discrete is definitely countable. That would be the key word there. Countable. 1, 2, 3, 4, 5. How many tenths? 5 tenths. Okay, I can count them. All right, so a little bit of practice here, and we'll deal with quantitative being a Q and categorical being a C, so I don't have to write too much. The ages and years of subjects enrolled in a clinical trial, that is definitely going to be a number that they give me back. So a number is quantitative. Colors of M&M candies, red, blue, brown, dark brown, yellow. Well, these are all colors, those are labels, those are categories. Doors in a game show labeled, oh, that's a very important word. The moment they tell you something is labeled, it is a category. Even though these labels involve numbers, that's kind of like those jersey numbers. The number of times contestants in a game show choose door number 1, you could watch an episode of a game show and you could count it. 1, 2, 3, 4. Okay, so that is quantitative. Now remember, if it's quantitative, then it's either discrete or continuous. So I'm just going to add a little bit here. The ages would be continuous. Time is continuous. Anytime you're dealing with time, you have a continuous measurement, but also you could be about 50, but I'm not exactly 50, okay? I could get this to the closest year, to the closest month, to the closest day. So that's a rounding thing. Number of times contestants in a game show choose, again, that is very countable. They're not going to choose it 3.5 times. That doesn't even make sense. This one is going to be discrete. And we're going to look at this, I think, more in a minute. That would be discrete. Categorical, you don't have to break down any further. Here's discrete or continuous. So on this one, we will use the D or a C to distinguish between those. Discrete is countable. Continuous means it could be in between or we've rounded it. So again, height, I think I used that as an example earlier. That is continuous. A lot of times you ask somebody how tall they are, oh, about 6 feet or about 6'2". Well, the very fact they said about means they rounded it. Number of cars serviced at a drive-thru in 1 hour, that one is definitely discrete. You are going to count them, 1 car, 2 car, 3 car, 4. You're not going to say 4.25 cars, makes no sense. Amount of time, you might have heard me and caught me saying that just a minute ago. Time is always continuous. Do you want this to the nearest day, to the nearest hour, to the nearest minute? Time involves rounding when we tell somebody how long something's going to be. Number of patients seen in one day, we don't see part of the patient. We're not going to round that off. It's going to be a certain number. You can count them. Number of rolls it takes, that one is countable. That one is discrete. The amount of blood, well, you would have to measure that in some way, probably in cc's, something like that. But because it's a measurement in between those things, that one is continuous. And decimals definitely make a lot of sense without us even counting. I don't have to count how many tenths. I could just say 2.3 cc's or something. So that's one practice of that. Remember, countable then is discrete, if you can just count it. Okay, besides what type of data, qualitative or quantitative, and then within quantitative, is it discrete or continuous? We also have levels of measurement. And these are listed really to get more specific as you go. So first of all, on the nominal level, there's no order. It's just categories, no order. Nothing is better or more than something else. So color is my example there. Blue is not more than red, and it's not better than red. It's just two different colors. They're just different. So if you're just saying they are different and putting them to distinguish between them, then it's nominal. Ordinal. Ordinal then lets us put things in order, whether it's first to last or smallest to largest, but you can't measure the difference between them, at least not by subtraction. You can simply say it's more or it's before. You cannot say that it's a certain amount more or how much before. Like a medium at McDonald's is not like a medium at Starbucks. And so they're just not quite the same, but we can say, okay, the small is smaller than a medium is smaller than a large, and you can't do large minus medium. So you cannot subtract. You can put them in order, but no subtraction. Now on an interval measurement, an interval and ratio tend to be the two that we have the most trouble distinguishing between. So on an interval order of measurement, you have order. The only one that doesn't have order is nominal. So we do still have order, but suddenly we can subtract. And we can say it is 3 more, or it is 2 more. But you don't have a real zero. What does that mean? That means 0 does not mean none here. Like if sizing, clothing sizing is one of those. If you've got numerical sizes, I don't know that men have this, but girls' sizes, or particularly young girls' sizes, they have a size 0. They even have a double 0. And 0 then, double 0 is smaller than a 0. It's one size smaller, so I can technically subtract. I can tell you how many different it is. So if you had a size 4 and you had a size 10, well, you could say, well, 10 minus 4 is 6. That's 6 sizes difference, unless, of course, they're just even sized. And then there's 3 sizes difference. But in either case, I can subtract the difference. But a size 0 doesn't mean there's no size. Another one that goes along with interval is temperature. We can measure temperature, and we can say, oh, it is 58 degrees outside, and somebody else could say, well, it's only 46 here. Oh, well, that's 12 degrees difference. We know which one is more, and we can subtract. However, even though neither one of those pieces of data was a 0, we know that 0 in temperature does not mean there is no temperature. It's simply a measurement on our sliding scale of temperature. So there's no real 0. So a key difference then on ratio, we still have order and we can still subtract, but on a ratio, you have a real 0, which means none. Another thing about ratio is you can actually do a comparison of like twice as much or half as much. I think I have that on the next screen, because that's really what ratios are about. This was 2/3 as much. So you can do that sort of thing with ratio measurements. but if it's 0, it means 0. So let's look at some of those things then. Which level of measurement are we dealing with? So we've got nominal, ordinal, interval, and ratio. Now, first of all, nominal, and let me just say it again, nominal is the categories only. Ordinal lets us put those in order, but you cannot subtract. On interval, we can put them in order and subtract, but there's no real 0. 0 doesn't mean none. On ratio, we can put them in order and subtract, and 0 actually means none. Body temperature. Anytime you're dealing with temperature, you can't be where 0 means none. But you could subtract. We could say, oh, this person's temperature is 98.6 and the other one was 98.4. I can subtract that and say that is 0.2 of a degree. So that one is interval. 0 does not mean none. Heights of students. Heights of students, I hope no student ever measures 0, but anytime you are measuring with a ruler, when you're measuring with a ruler, if something measures 0, then it means that there is no height, because you're never going to have a negative height. So this one is a ratio. Somebody that is 4 feet tall is twice as tall as someone that is 2 feet. So a toddler versus your elementary student, you can be twice as tall. And again, that's over here on the right. Ratios can have something like half as much or twice as much. Class times. Time, if it's talking about how long does this class last? Well, if class were canceled, it would last for 0 minutes, and that would actually mean none. And you could have a class that you set in for twice as long as another one. Responses of yes, no, and undecided, those are nominal. We're not going to put those in an order and say that yes is more than a no. You can't subtract it. Small, medium, and large, on the other hand, we can put in order. They are listed in order right here. But you can't say large minus medium and get an answer. Marathon finish of first, second, and third. Well, almost those little I don't know that they're called subscripts, superscripts of the ST, ND, and RD. Those little things indicate, that's what we use in our language to indicate order. These are ordinal. You can't subtract them. It doesn't make any sense to say, oh, well, the difference between these is 1. Because really, this is simply the order. The difference between the first one and the second one could have been like 100th of a second. And yet the difference between the second and third one could have been minutes. So it doesn't make any sense to just subtract that order. And I used this one earlier, the number on a player's jersey. See, that's just a label. That is nominal information. That is just so we can name them. Make sure you make yourself some keynotes to help you with your homework, or maybe freeze frame back up to that previous slide and take a picture of it so that you can get those. Okay, and then our last slide for this particular section, what's wrong with the calculation? We've talked about some things within this lesson. So let's just say, just because something has numbers doesn't mean the calculation that somebody is telling you makes any sense. All right. Here on this first one, they've done an average of jerseys. That's what's wrong with it. Jerseys are just labels. Jersey numbers are the labels, so it doesn't make any sense to do any math with those, whether or not you're adding, subtracting, finding averages. That is the problem. Don't average something that is nominal. It's just the name. If the top 3 universities are number 1, Princeton, number 2, Harvard, number 3, Yale, the difference between Harvard and Yale is the same as the difference between Harvard and Princeton. No, this is a ranking. And when you are talking about rankings, that means that you can put them in order. And just to remind you, I'm going to back up a couple of slides so you can see this information. If it's in order, but you shouldn't subtract it. And that's what we mean there. So we're going to put them in order, but we should not subtract. And if you can't subtract, then you can't measure that difference. Do not subtract. I mentioned this one earlier too. A girl wears a size 2 in a particular brand of jeans. Her best friend wears a size 4 in the same brand. The girl is half the size of her best friend. Well, 2 is half of a 4, but in terms of size, size is a little bit different. So let's look at that again. A size, we can say it's more and we can subtract, but there's no real zero. And if there's no real zero, because size 0 doesn't mean no size, then you also should not be doing twice or half. So this particular one is interval measurement. On interval measurement, where there's no real zero, you don't want to use any comparisons like 2 times as much or 3 times, which is what twice means. So do not use, and I'm just going to kind of write it out here because it gets a little bit more complicated if I try to use real mathematical words. So don't use twice or half or any other terms like that with interval measurement.